Now if you look at the hydrogen atom, in the nucleus you got one proton having a charge of plus E and one electron is moving around it in a circular orbit. The electron is getting pulled by the nucleus. The nucleus is also getting pulled by the electron. So why should the electron only move? The nucleus also should move. So actually, this proton, which is the nucleus here, and the electron move about their common center of mass. Same is true for sun and earth. If suppose nothing else was there, only the sun was there and the earth was there. The force of the sun on the earth and the force of earth on the sun, both will be exactly equal. The mass of the sun is much larger than the mass of the earth. So the acceleration of the sun will be F by capital M and acceleration of the earth will be F by small m. This acceleration will be large, but this acceleration will not be equal to 0. It has some value. So even if the sun and earth are only there, the sun will also slightly accelerate. Same way for the electron and the nucleus. The electron moves around the nucleus, but the nucleus also will get affected by this, and the electron and the nucleus will move about their common center of mass. To take care of this effect, we have to replace the mass of electron by its reduced mass. So mass of electron has to be replaced by its reduced mass. Reduced mass mu is defined to be equal to m divided by 1 plus m by m. This small m is mass of electron. Big M is mass of nucleus. If we can neglect this term, which we can do in most of the cases, then this mu becomes exactly equal to mass of electron. Otherwise, in all the equations, it will replace the mass of electron by its reduced mass. Okay, this explains why the emission spectrum of the various isotopes of hydrogen are different. The mass of electron will remain the same, but the reduced mass is going to change. Now we will take up one problem. Find the kinetic energy, potential energy and total energy in the first and second orbit of hydrogen. If potential energy in the first orbit is taken to be 0. So to find kinetic energy, potential energy and total energy in the first and second orbit of hydrogen. But we are taking the potential energy of the first orbit of hydrogen to be equal to 0. So how do we solve this? Because potential energy has become 0. To understand this, let us take a simple example. Suppose this is a cliff and there is a lake here. A nice lake is there and one person is flying here. Okay, the height of this person from this place is say small h. Height of this person from the bottom of the lake is say h1. So its potential energy with respect to ground will be mgh, right? His potential energy with respect to bottom of the lake will be equal to mgh1. Right? As the reference line for potential energy changes, the potential energy values change. But kinetic energy depends on velocity. So kinetic energy will always be equal to half mv square. Kinetic energy does not depend whether you change the reference line from somewhere to somewhere else. Okay? So kinetic energy at the original value, that is 13.6 electron volt, that depends on the velocity. It does not depend on from where you are measuring potential energy. So kinetic energy will have a value of 13.6 electron volt exactly as earlier. And total energy will now be the sum of these two, that is equal to 13.6 electron volt. So kinetic energy values are not going to change. We change the reference line for potential energy from where we are measuring potential energy. Now what happens to the second orbit? Suppose the height of this lake is delta H. So the difference in these two potential energies, which is UB minus UG, will be mg into delta H. Now suppose one more person is flying here and the height at which he is flying with respect to the bottom of the lake is say equal to capital H1, and this height is capital H. Now if we know mg delta H, we can find this potential energy. If we know this potential energy, U with respect to ground will be mg H. U with respect to bottom of the lake is mg H1. Delta U, which is UB minus UG, will still be equal to mg delta H. So when the reference line for potential energy is changed, all potential energy values increase or decrease by the same amount. Earlier we were measuring from here, so we had some values. If you start measuring from here, all the potential energy values will increase or decrease by the same amount. So here how this has become 0? Minus 27.2 of the actual value. If you add 27.2, you get 0. So here actual value is minus 6.8. Plus if you add 27.2, you will get the value of 20.4. This is the energy here. So potential energy equal to 24.4 electron volt. All potential energy values will increase or decrease by the same amount. So this potential energy value has increased by 27.2. So this potential energy value also has to increase by 27.2. Right? Now once we know this also, because this will not get affected. This does not depend on what we are doing with potential energy. So this will still be 3.4 eV. So total energy will be 23.8 electron volt. So several important things you can understand from these two examples. First important thing to understand is mgh represents the change in potential energy. Second important point is when the reference line for potential energy is changed, all potential energy values are going to increase or decrease by the same amount. Third important thing is that when the reference line for potential energy values are changed, kinetic energy values are not going to get affected. Kinetic energy values will remain as it is because they depend on velocity, which is not changing. Another important thing to understand here, that relationship K equal to minus E and potential energy equal to 2 times E is valid only when you are looking at absolute potential energy. Here you cannot start applying those equations. Then you write everything as 0. That is not What is right?